So, Guillaume is a research engineer who decided a while ago to learn Zig. Like many others in our circle, he has a troubled past where he was forced to program in C++. And in his case, that happened at a company that has "Don't be evil" as its tagline, ironically enough. Nowadays, he mostly programs in Python, but I guess he still has a need for speed, which brings us to today's talk. The title is Rewriting an NLP Tool from C++ to Zig. Guillaume, the stream is yours.
Hi, everyone. Yeah, so I wanted to first introduce what this tool is about and how did it go with the rewrite, some benchmark number, and then I'm going to talk a bit about a Python wrapper I made for it, and we proceed with some conclusion. So first, so the algorithm FastBP, it's called bytes per encoding, and it has been made in 2015. It's been used in a lot of natural language processing papers and research, mostly working with neural networks. And I wanted to, so the original says in the C++ implementation, which are already pretty fast. The name, it's called FastBP because the first paper back in 2015 published a Python implementation, which was quite slow. And I wanted to learn Zig. And I thought it would be a good fit because there's 500 lines of code, so it was a small project. And I was impressed by the Road to 1.0 talk from Andrew, and I wanted to check this claim that Zig can be faster than C. So first, what's byte pair encoding? And so when you work with text, the first thing you want to do is split it into words, mostly because words are actually convey a lot of information, and learning a neural network for any task would be far easier if you start from words instead of starting from characters or bytes. The problem, of course, is word isn't a well-defined concept. It's language specific. For instance, isn't in English is often considered by most tokenizers as one word. But if you look in French, you have this word kill. It means it is mostly considered as two words, so you can't use the single quotes as a word separator. It's not always the case. It's not in English, but it is in French. And also some languages don't really have words. I can mention Turkish or Chinese. In Turkish, it's very common to slap words together and make very long words that you won't never find in a dictionary, but they will appear when people speak between them. So of course, the tradition for this tool is to have regex tokenizer, and so for each language you will have a lot of specific rules. Some language use dots, for example, in date, or they use dots in currency. So you have to handle them specifically for each language. So of course, it assumes that you know the language of your text, which is not always the case when you're working with text that come from the web. And also it creates another problem, is that you have a very large vocabulary. And that's particularly an issue for neural networks and language models. Language model is a kind of machine learning algorithm that tries to predict the next word in a sentence. And if you have a vocabulary of 1 million different words, you have to generate a probability over 1 million words. So first, it's costly to compute, and it's also hard to learn a good distribution. And even if you have 1 million words of vocabulary, you will always find words that are outside of your vocabulary, that your model doesn't know how to handle them. And it would be proper names, person names, small cities. It will also be, also mentioned before, like for Turkish, you will have people making new words, or so on. And even if you have not out of vocabulary, you will still have some words which are really rare and that your model has only seen like once or twice in your full training data set, and it doesn't really have a good representation, a good idea of what to do with them. So byte pair encoding solution was to split the text in frequent chunks of characters. And so I put an example. I'm eating some apples, might get tokenized like that. So you have I'm, and eating will probably be split into two parts. One is the common word eats, and so ing is also very frequent in English. So you hope that your byte pair encoding algorithm will keep it as one chunk. And it's a good compromise between linguistics, so it's not like what a linguist would call correct speed. The algorithm is also pretty fast. And also you can have a good control on your vocabulary size. And like for something like under 500,000, you will have a good coverage for English. And if you go up to 200,000, you can cover like all languages at once. I wanted to say that this algorithm is not really state of the art anymore. If you want to use something like this right now, I would recommend rather sentence piece, but I still choose byte pair encoding because first the code was quite straightforward. And I also knew the person who wrote the fast byte pair encoding implementation in C++. So I figured out it would be easier for me if I had questions. And the main issue with byte pair encoding, I mentioned in the blog post, is that it's using word frequency, and some characters, like the dot, you will have some artifacts, because since dot is a very frequent character, it will always, every letter that is followed by a dot will be a frequent pattern, and you will have a lot of this pattern with a dot at the end, which is not really something that you really want. And the underlying theoretical flaw is that byte pair encoding is only using row counts of patterns instead of a pointwise mutual information. So I can come back on this if you're interested. So the algorithm is as follows. At train time, you use some very basic tokenization. So you split on all spaces, new lines, things like that. And you count each n-grams, each pattern, how often it happens. So I'm talking about all the pattern of letters. And at inference time, you will start, first you reuse the same basic tokenization on spaces, and you start by splitting all the characters into the different group, and then you try to merge them, and you start by always merging the one with the highest score, which is the score is like how many times you saw this pattern in the training corpus. And you merge like this. First, here in the example, I have eating, all letters are spread out, and you start by merging the E and A, and then maybe the N and G and I and G. The only order is the scores of those. So the algorithm is like mostly linear. You have a small quadratic component in the length of your words, but you can assume this is relatively small. And okay. Now I'm gonna move on like what I did to rewrite in Zig. And first there was some issues with the C++ implementation. So C++ was like pretty, I would call it idiomatic, but it made an easy use of a standard library and vectors, appending to vectors, and string concatenation. So there was a lot of vector creation. So every time you would create this list of token, every new step you will create a new vector with a new list of groups. And also, you will also concatenate the characters one by one to store them in the token list. Yeah, so the thing is, like, if my goal was not necessarily to make it, yeah, my goal was not to make the tool faster, but when I rewrote it in Zig, you realize quickly that allocating a Zig is a bit painful. So you try to think about twice when you do it. And what I did, like for the vectors, instead of allocating a new vector each time, I just have two vectors and then I swap them at every round. I have always like the current state and I have the new states. Small optimization like that. And also the strings, they are not concatenated, but since I'm using slices, concatenating two slices is like free. I just, recompute the end of the slice and I have a new slice. And also, one of the things you have to do when you write Zig code and you try to pre-allocate the memory is you need to think about like pathological edge case. And in my case, like I have a buffer that stores the current word I'm processing. And I decided that it cannot be greater than 4K bytes. And then if it's greater than that, I can just, currently I'm just keeping it, but I could just, split it in some arbitrary size chunk. It's not really an issue in any case. I probably can just replace it also by a node token or something like that. So that's the kind of thing that if you feed this kind of word to the original implementation, your model will take a very long time. Typically, if you give some Chinese text, which doesn't have any spaces inside it, you will just have your code going very, very slow because you ate like a pathologic edge case that nobody had ever thought about. While in the Zing implementation, you kind of have to think about those, and you will have something which is not great, but at least your process will exit in a reasonable time. Okay, so now moving on to the benchmark. So I only evaluated the parts that apply. The by pair encoding, I didn't evaluate the part that trains. I did some benchmark about the training too. It was similar. Suppose two implementations are pretty close together. So I'm just gonna focus on the apply parts. So I used an extract of French Wikipedia, and all the implementations, they produce the exact same files at the end. And for C++, there was two implementation. One that takes the whole file in memory and treats it with 4 threads. And the other one read from standard inputs and process line one by one in a single thread and write the result to standard output. And this is the only thing I implemented in Zig. First, because I still don't know yet how to make multi-threading works in C++, in Zig, but also because, most of the time I don't have my corpus lying on one file. Like I have a text file which is 4 terabytes long and it's compressed. I don't want to load it in memory, and also don't want it to store it uncompressed on my disk. So I don't want to map it or something. Anyway, let's move on to the benchmark results. So basically, like the C++ implementation is 3 times slower than the Zig one. And I think it's important because currently in natural language processing, most of the time people will do all the preprocessing offline before training because it takes time, but in turn you lose reproducibility reproducibility, and also, yeah, because typically sometimes people will distribute data sets that already applies their own preprocessing, their own bypass encoding, and then at some point someone lost the model and you cannot ever redo it, or you cannot reuse the original text. Anyway, so yeah, the Zig implementation is faster, and yeah, but that's not really surprising considering I had to change the memory allocation, and yeah. Now let's talk about Python proper. As Christophe said, I work a lot with Python, and a lot of neural networks these days are trained with Python. At least the logic that loads the data and describes the neural network is in Python, and then Python call CUDA kernels, very optimized codes. And so, yeah, it's very common to use Python bindings. There's different ways of doing Python bindings. You have Cython, which is like a Python-like language, but that can be compiled. But it's not really Python because Python is highly dynamic. So you have some kind of subsets of Python. You have also PyBind11, which is a C++ library that lets you manipulate Python objects. So you can take, so you literally have a strict called PyObject, and you can set fields. And so you can, it's basically you have to learn a lot of things, and you can manipulate Python directly, which can help. But it also means that you generally can't leverage C++ libraries because they're not meant to work with Python object anyway. And then, of course, you have a CFFI for Python, and you have two ways of calling C function. There's CFFI and C-types. I use the second one, C-types. I think it's a bit more modern. So the benchmark code is doing only the processing in Zig. Everything else, like reading the code file, is made in Python. The idea is I wanted to benchmark a case where where you have the maximum flexibility, because you can also call a function in Zig that's load the file, read it, and write the result somewhere else. But when you want, but that's not the typical use case of people using Python. If people are using Python, it's because they want more control over what's happening. Maybe they want to add more processing steps and so on. So yeah. As it happens, like most Python wrapper are about the same performance of the original code. Cython is a bit faster than C++. I don't know why, and C-types is a slightly bit slower, but as I will explain later, I thought it would be I thought the difference would be bigger. So coming back a bit to, so I did some profiling of the two Python wrappers. So the first one, I'm not going to spend much time on it because I think it's pretty messed up. Flame graph, when you have something compiled with O3, it's really a mess. The code stack is really not preserved. All I can say is apparently it spends a lot of the find method of that dictionary, which is at the core of the algorithm. And they also spend a lot of time doing pushback. And I think this is because of them not pre-allocating vectors And the Zig flame graph is much cleaner. It's really more easy to understand what's going on. You have actually a big part, which is like this part. Answer capacity exact is called like 25%. The time, as this is only called during loading of the model. So I can probably be more aggressive here by pre-allocating more memory right out of the box, or And also, yeah, there's like 40% which is copying back the results from Zig to Python, which is here in this part of the flame graph, if I remember correctly. Oh no, it's here. Yeah, I think it's here. And also you have spike pi c functor pointer call, which is like 6%. So the two, and so you have like 20% overhead when coding Python. That's why I was expecting the overall code to be like 20% slower, but it's actually about the same speed. So I guess there's something else. Sorry. Something else going on. I think probably, I don't know, maybe some part of the Python code is actually very fast. I don't know, maybe it's reading files from Python, which can be explained if they have, I don't know, bigger buffers, things like that. I haven't dug in this part. Yeah, so we are reaching to the conclusion, and I wanted to make a few comments about the Zig Python interface. And the thing is, I have to expose a C function in my Zig code, so it looks like something like this, and it's not really nice Zig. You can see, like, I have to send take a pointer and a length. And similarly, on the Python side, I take the sentence as bytes, and also have to declare the type of my function here. It also makes for like a function which is not really Python friendly, because I also have to send the sentence and its length, and also have to pass a buffer. So yeah, so I think this part is a bit repetitive. I don't know how we can make it more easier, either with better. I was wondering, maybe I could ask the compiler to generate for me a Python files, which could expose this kind of function instead of exposing these ones. Yeah, but I haven't proceeded into that. I don't know if a lot of people are working with Python and Zig. I'd be interested to know if there is a niche. Yeah, so as I said, there's some to-dos. I want to do, yeah, I'd like to improve my code with adding multi-threading, with using async await. I'm not exactly sure what would be the right level of synchronization between my different async await procedure. So the pain points I had with Zig at first, obviously, that I need to think about memory allocation all the time. And yes, thing that I never realized before, I need to think about it, like resolving a file path. You have a path to a file name, and you want to know the full path to be able to actually run the file, and just for that you need to allocate memory. And so, I mean, yeah, some part of your code, what you would like to not pass the allocator, you still have to. Also, I was not used to this level of error handling. I think it's very interesting. But it's, yeah, in a way, it also remind me a bit of the old Java days where you had to expose all the errors you can return in the function signature. Yeah, also I was surprised to find that even in standard libraries, you have a lot of private members and functions. Typically, yeah, so I have a hash map, and I want to print all, so the key is a string and the value is a score. I'd like to print them all sorted by score. And basically, I would like to call array.sort on the underlying array used by the hash map, but I can't because it's private. Yeah, and so I need to copy it, which is a bit weird for me. And so, yeah, so I'm not sure why there's so many private members in the function into standard library. Coming from Python, it's a bit surprising. Yeah, and also for a language that claims to be like C, it's also a bit surprising for me. But anyway, as I also mentioned, the Zig Python interface is a bit cumbersome, a bit verbose, I would say. even though it seems to be reasonably fast. Yeah. But I just want to say I still had a good time writing Zig. I found it refreshing. I also think that the Zig source code is pretty great. Standard library, it's better, way better than the automatically generated documentation. And also it's a good source if you want to learn the language. And yeah, that's all for me. Thanks for listening. And I'll be happy to take some questions.
Okay, awesome. Let's switch to the Q&A view. So while people start thinking about questions, and by the way, like before, if you have any question and you are not in Twitch chat, but you are in Discord or IRC, feel free to send your questions there. I'm opening up all the relative windows, so I won't miss your question. Okay, so Guillaume, in the meantime, let me start by asking you let's say the standard question. When and how did you discover Zig?
I think it was in March during the lockdown. Yeah, I don't. Yeah, or maybe no. I think no. I think I heard about it earlier. Yeah. So at some point, someone was asking me. Yeah, there was some interest group, and some of my colleagues wanted to learn more about C++, and I was like, I really wanted to say to them, like, don't learn more about C++, just learn a good language and add don't anything to propose them that would be better. And so I started hunting around the web, and I first found J, which doesn't exist actually. And I finally heard about Zig. I think it was around January. And yeah, and then I found yeah, I was looking for a first project, and I decided and starting during the lockdown.
I see. So you started very recently. That's good to know.
It's very recent.
Okay, so another quick question. Maybe I am misremembering, so feel free to correct me. But I think I remember a while ago I was also experimenting with. I was taking a look at calling Zig from other programming languages, and I remember also trying with Python. I think I remember CFFI also having a static way of loading, basically CAB binaries. Yeah. I might be misremembering though.
I didn't look a lot into a CFFI. Just yeah. Okay. So maybe I'm wrong.
I see. Well, the reason why I'm bringing up CFFI, I think your point about having the the integration code be automatically generated, that sounds perfectly reasonable, and I think it's something that that, by the way, would be, I think, easy to implement as a userland library. Like, I don't think you would even need anything special from the compiler.
No.
Generally speaking. But that said, the reason I brought up CFFI is because, like, at least in my case, I had an easier time with that, because CFFI loads, like, it can parse header files. So I remember being able to use the automatically generated header file by Zig to get function definitions.
Okay.
Yeah.
I didn't thought about that. I remember seeing something about the header file, but I wasn't sure how that would apply to Zig.
To be honest,
Zig has
Sorry?
Zig has a translate to C somewhere function?
Not exactly, but it does have a. So when you compile as a dynamic library your Zig code, you also get. Maybe now it's broken, so I'm not aware of the current state of things. But the Zig compiler can generate header files whenever you export something with the CABI, and so that came in handy, at least when I was experimenting. But that said, maybe you didn't care much because, as you mentioned about the speed, like I never really cared about how fast the integration was, and when I tried, I just wanted to make it work. So that's why I settled with CFFI. Let me see.
I look into it.
Let me see.
I look into it.
Okay, let me see if there's questions. So there's one in Discord. Wait, that's in French. Oh my god. Man, fan code. I am the one that has to read those to the speaker. Why are you making it harder for me? You have to be subjected to my French. No worries, no worries. I want to do this. I want to try this.
Okay. I also have Discord. I can.
Okay. Quel est ton prochain project en Zig?
Oh yeah. So what's my next project in Zig? I don't know. Maybe like a mentioned sentence piece. Maybe I will look into that. It's a bit more. Sentence piece is also making use of protobuffer. So maybe I look into generating protobuffer API for Zig or something similar. Yeah, I don't know, but I also want, the very next thing I really want to do is this multiprocessing, because I really want to understand how it works. I think a way it seems cool from what I heard about it, because I haven't really practiced it. So I want to do that first.
Okay, let me see other questions. This one is from Andrew. Can you share more about your NLP project? What are you working on in terms of like big picture?
So I'm a Facebook research, and I work on, so basically we train several, I don't know if you heard about GPT-2, GPT-3. So we're also doing things which are similar. So that's mean training big language model on a, hundreds of gigabytes of text called from the web. These models are then used for classification tasks. So abuse detection, hate speech detection, and more recently, I'm more focused on content retrieval. So you have a piece of text, and I want to, like a Facebook post, and I want to find other Facebook posts that says similar things. Or it can also work with newspaper articles. And it's better if it can work across several languages. Yeah.
Okay. Yeah, there's another question by Dirk Code. Would you use Zig at your day job?
So I don't choose Zig at my day job. I'm considering it. For now, it seems a bit hard to promote it in my day job. Just like typically, I wanted to recompile my code before the presentation. And I don't know why, I also upgraded the Zig compiler. And of course, there was a lot of warnings. So I think for now, it's a bit unstable to use at my day job. And also, like typically for this project, the speed is not really that important, because we are talking about models that use hundreds of GPU hours to run. So spending 3 more times for the pre-processing is not that a problem, because it's only CPU. CPU is cheap in comparison. So I don't really have a good case right now. But if I was, unless I'm starting a new project which I need to write in a low-level language, I don't think I will use Zig at work. But if I do, I look into Zig.
Okay, well, I can say that for the people watching, if you are interested in trying to introduce Zig at your day job, I think as Guillaume said, it's a bit early for Zig to be used, I think, in production, generally speaking. But if you want like a couple of life hacks, one is to wait for us to get to the self-hosted compiler, and wait for us to be to a point where it's easier to ensure that the feature doesn't break. And at that point, maybe you won't stay on the unstable branch, right? Because then you will get breaking changes. Like I think for Guillaume, what got him was a change in the hash map implementation, right?
Yeah.
While if you stay on a tag release, then that won't happen. And at the same time, though, the idea is that once we get there, we'll be able to provide like stability patches also for certain features that we want to keep stable. The second life hack that I can say is that, for example, again, it's not really, I don't know if it's used in production right now, to be honest, because I don't work there anymore. But at least in my case, what I did was I implemented a module for Redis that we were using at our job. This is not as during my work at Redis Lab. This is before, so it was actually used to do stuff, not just by Redis Labs itself, but it was on my previous job. And what I did was it was a very small library, very small in scope. And the thing is, it was a piece of software that you could consider basically mostly done. It works. It's not going to break. The scope is not going to change. And once you compile it, it's compiled. So as long as you don't change our CPU architecture, you're done. You have the compile executable, and you don't have to worry about much else. Anyway,
I think for my case, like FastBP, encoding is still used by some teams, and if I could give them a binary that just works, I think they'll take it. The only thing is, like, for now, I didn't implement the multi-thread thing, and that means that for some use case, it will be slower than the original one. And I'd like to be on par on every axis before pushing something new.
Yeah, makes sense. So let's see. Just checking the discussion on Discord, but no new questions. Okay, so I think we got most of the questions. I think I have one last question for you. So, for the people watching, Guillaume also published a blog post about his experience doing this work with Zig. And if you're interested, I think you can find the link in a few places. Did you link to it in the repository?
Yes, in the repository, and it's also, I put it in Zig Showcase in the Discord at some point, but you probably have to scroll back up a lot to find it.
Yeah, I also added it to the newsletter. So
okay.
If you caught the last newsletter, or if you want to check the archives, you will find the link. And so I read it, and in there you were pointing out that one of the limitations that that BPE has is that it's based on frequencies rather than on mutual information. Would you be able to like explain this a little bit to the viewers?
What I can say is, like, so for BPO, what you count is you look at all times you have a group W1 of characters that appear next to W2, and so that gives you the score. So it's just the number of times you see it.
Yes.
Sorry. And what I want more materials information, you would normalize by the number of times you see each characters independently. All right. Yeah. So first, and we are gonna pass that into probabilities. And what does that mean is, this is the probability of the two of them appearing together. And this is the probability of the two of them appearing together, even if they are totally independent events. So in my example with the dot can appear next to almost any letters, but it's not as much because the dot is something that often comes after some specific word. Because most of the case, most often it's just because the word is actually very present. So if W2 is a dot, you will have this probability, which is pretty high, and so the score for this, the PMI, will be low. Whereas for the bipair, for just the count will still be very high.
Okay, that makes perfect sense. So if people are interested more on these, I don't know, computer science, statistics, like less just low-level software engineering part, take a look at his post. I actually, at his write-up, I enjoyed it a lot.
Okay, thanks. Yeah, it's
Yeah.
actually the first time I like write a blog post, and yeah, I already spent way too much time on it, but it's really not as good as I want. But yeah.
It's always like that. Well, it's just a matter of practice. Okay, so Guillaume, is there anything else that you want to say before we move to the end of the show?
No, I'm good. Like, thank you for having me. I think it was a fun experience. Yeah, the more I'm hanging out with the community, the more I like it. So maybe you have not done seeing me.
Okay. Well, it's been a pleasure. I'm looking forward to hearing again from you, both in a Showtime talk or even just a link on the Showcase Discord channel. By the way, if you are interested in doing stuff like you mentioned earlier, a library for protocol buffers. I think probably there will be other people in the community interested in this stuff. So consider also telling about people early. Like don't just put the link of the completed library in Showcase. You might find somebody that wants to help you. Okay, that was great. Thank you very much.
Thanks. Bye.
Bye bye.